guys know what this means.
I knew it.
I love that. That is so cheesy.
Yeah.
Plus or minus
I knew what that meant yesterday.
Whatever. So here's what happens. We're going to start by talking about how we add or subtract what are called complex numbers. Now, what happens here is the book likes to go through this whole long worded thing for all this junk putting together for how you deal with a complex number. Now, I don't want you to write any of this out, but I just want to define to you what a complex number, how it is written. When we write out complex numbers, you're going to see them written in parentheses sometimes. Sometimes you see them without. It's always integer first, plus or minus the other value with the I. When you're writing out, we've been doing that when we had our solutions. Remember I would say 3 plus or minus I root 2 or whatever your answers were, you were putting in what's called that standard form. The standard form of a complex number is basically A plus B I, where A and B are integers. And remember, it can be plus, it can be minus. Believe it or not, it's crazy that the timing works out well here. Pre-calc right now is working with the same stuff you guys are, as far as the complex numbers and stuff are concerned.
So we're smarter than them.
I wouldn't go that far.
I would.
Now,
I'd say it's stronger.
what I want you to think about when we're dealing with complex numbers, I want you to treat the value of I, when you're adding and subtracting, like you would treat it as a variable. And basically what I want to do here is, all we're doing is combining like terms. When it comes down to adding or subtracting complex numbers, I'll move this up here for us. When it comes down to adding, subtracting complex numbers, basically the scenario of which I want you to look at is they write their complex numbers in parentheses. What I want you to do, if it's an addition problem, is to rewrite it without them. Yeah, it'd be helpful. Because from here, all you're doing is combining like terms. What's 4 plus 3? What's negative 1i plus 2i?
I.
And notice how I put my integer first. First. It's always goes 7 plus I. That's it. All you're doing is rewriting without the parentheses and combining like terms. Now, when it comes to subtraction, there's a little trick. What's that? No, what I want you to remember here is this is a complex number, subtract the other complex number. What I want you to do is make sure you distribute the negative to both terms. So when you rewrite it, you get 7 minus 5i minus 1 plus 5i. You're distributing the negative 1. Because it's basically, this is 7 minus 5i minus 1 times the quantity 1 minus 5i. So you're distributing the negative 1 throughout the terms within the parentheses, and now combine like terms.
So,
The answer is 6. What happens when you're working with adding and subtracting of complex numbers? It's one of the easier things that we do. All you have to make sure is you combine your like terms and watch the negative when you're distributing. Okay? That is normally where students will mess something up. You'll distribute to the first term, but forget to send it to the second. Okay? Let me show you another one. 6 minus 3i minus 8 plus 4i. No. We're not solving for I here, but I just want you to kind of treat it like it is a variable by using the same ideal properties, if you will. Distribute your negative. You get 6 minus 3i minus 8 minus 4i. What's 6 minus 8? Negative 3 minus 4. Not so bad? Okay. Now comes scary stuff. Multiplication. When you're dealing with multiplication, what I want you to remember, I squared is equal to what? Negative 1. Thank you. More specifically, it's negative 1. All right? Also, the square root of negative 1 is I. Okay? When I'm multiplying, I take the following.
What is I squared?
Oh, negative 1. When I get to this part, all I have to do is distribute. So you distribute in, we get 6i
Minus 2.
minus 2i squared.
But it's because so it's just plus 2.
Very good. Now, and this is where it becomes very important that you remember that I squared is negative 1. So when you're multiplying things out, anytime you have an I squared, what I want you to remember to do is write out as 6i minus 2 times negative 1, which becomes, now, very good. And that was my last part here. I get 6i plus 2, but how should I write that to be? Always put your integer first. Okay? The trick, it's not that it's really difficult. The trick is to remember that I squared is negative 1. So when you're distributing things through, sometimes you might just have to rewrite it at the end. Okay?
Alrighty.
All right. Now, what do you think is going to happen when you have this? Oh. What's that? I think you're right. So now in this case, it's nothing more than foiling. We still multiply out like you would normally. You go through your first, outside, inside, last. First, outside, inside, and last. Combine your like terms like you would normally. And what do I want to do here with this I squared? Write it as negative 1. So now I have minus 8 times negative 1. So this is negative 7 plus 18i. Remember, negative 8 times negative 1 is positive. Yeah, I was just waiting for you guys to get caught up. Now my last thing is just to combine my like terms again. And do I put the 1 in front of the 18i or behind the 18i? In front.
And front.
Thank you for chiming in.
Circa day.
In front.
It's actually in front.
That's
No, it's
I
Wednesday.
just did him in Spanish.
It's Wednesday.
Mr. Murphy, what are you doing for Christmas?
Waking up.
We still haven't gone on that fishing trip.
Oh, that's right. We were supposed to go on a fishing trip.
We were. Remember?
No.
What are you bringing in the bow and arrow?
Yeah, even better question. When are you bringing duct tape for Cassie?
I'm sorry, that was well played.
Stop, Willis.
What you talking about, Willis? I've never heard that before.
Yeah, only like 6 million other times.
Now, do you guys notice a pattern in this one?
Same
The
numbers.
difference is do you guys remember when you had this, x plus 2, x minus 2? When you did that, did you have the middle term? No. You get x squared minus 4, right? Well, it kind of follows the exact same pattern here. If you FOIL it out, you get 36 minus 18i plus 18i minus 9i squared. what happens to that middle term?
Vanishes.
It drops out.
Sayonara.
So you get 36 minus 9 times negative 1.
45.
You get
54.
Not 54. That's.
You're still staring at it, you alright?
I'm good. Oh, yeah, me, yeah. I got you.
Remember, in this case again, when it multiplies itself out, that middle term drops, and all you have to really remind yourself to worry about is that I squared. So again, I get negative 9 times I squared, which is negative 9 times negative 1. You get plus 9. Okay? Multiplying these out is a relatively easy process to do. You follow these same exact rules as you would of FOIL, but you just have to remember the I-squareds. The only tricky thing of doing any of these works with division.
I knew you were going to say that.
Of course, why wouldn't I? Now, when you're dealing with division, what I have now is 5 plus 3i over 1 minus 2i. And what I want you to think about is, what did you do when you had a radical in a denominator? You would get rid of it by multiplying it out, right? You're kind of doing the exact same thing here, but what you're doing is a process called multiplying by a conjugate. Think about the problem we just had. 6 minus 3i, 6 plus 3i. When you multiplied those out, the i's went away, right? Okay. A conjugate is basically the following. The same values with opposite sign in the middle, with an opposite operation, let's say that. So if I want to get rid of this 1 minus 2i in the denominator, I multiply by 1 plus 2i.
Really?
This conjugate here, if I'm multiplying the bottom by 1 plus 2i, to keep the fraction in terms of 1, what do I multiply the top by? I multiply it by the same. Because this fraction here is equal to 1. So what we wind up doing again is we FOIL out. I get 1 on the denominator, I get 1 minus 4i squared. There's no middle term. I squared is negative 1, so this becomes 1 minus 4 times negative 1, which is equal to 5. So what I'm doing here is I'm working with my denominator first. It's the easier one to deal with. Okay? It's a little bit easier to deal with. Now, in the numerator, all I have to do is FOIL out, combine like terms. So when I FOIL out, I get 5 plus 10i plus 3i plus 6i squared. I'm going to bring that down here so I have a bit more space. So that's the same as saying 5 plus 13i. And what's 6i squared equal to? Negative 6. Good. So my last part before I put it back over 5, what's 5 minus 6? And you're done. I have now gotten rid of the imaginary number in the denominator by multiplying out by the conjugate. Remember, when I multiply by that conjugate, it really is just a shape change of a multiplied by 1. Okay? That is the trickiest of them all that we work with when you're multiplying by conjugates. Because you have to FOIL twice. Okay? Watch signs. Okay. Let's try another one. Okay? 3 minus 2i over 4 plus 3i.
Like.
What day is it?
Anyway, what's the conjugate of 4 plus 3i? So that means I'm going to multiply the top and the bottom by 4 minus 3i. My denominator, 16 minus 9i squared.
Yes.
So it's 16 plus 9, which is 25. Everybody okay with that?
Yes, sir.
16 minus 9 times negative 1, 16 plus 9. In the numerator, once again, when you FOIL out, you get 12 minus 9i minus 8i plus 6i squared. What's negative 9 minus 8?
17.
Positive or negative? So I have negative 17i. It's going to be over 25. And then what's 6 times I squared?
6.
Negative 6.
Wait.
6
Oh.
times I squared.
I got
So
it.
it's be
Yeah.
negative 6.
Yeah.
Negative 6 and 12 is,
I was thinking the 7.
okay. And then you're done.
That's what I was.
Oh.
Hey, Mr. Murphy,
Yeah.
when are we gonna use imaginary numbers in real life?
Electrical stuff.
Electrical?
Yeah. Electric voltmeter, stuff like that. You use it a lot in engineering. You use it a lot in electrical engineering, things like that.
That's what something something like.
But they're talking about it. Some of the way the calculations work out. We get to it again when we do some more modeling. Now, one thing I will show you that the book tends to do with when you're working with conjugates, there are some times that you have an answer. You might get an answer that looks like the following. 18 minus 12i all over 20. I don't know.
Yeah.
What can you do to everything there?
18 over 20 minus 12i over 20.
I can divide everything out by 2. What the book does is that it takes it a step further, is that if you can simplify all 3 values, it simplifies them. Okay? So you get 9 minus 6i over 10. You want to simplify it out as best you can. Okay? So what I'm saying here is make sure that when you wind up with a complete fraction, if you can, simplify it out. You don't have to break apart the fraction. You can leave it like that. No, it's in the numerator. I'm saying that if your solution, if your answer was this, you can simplify everything out by dividing it by 2. That's what I'm talking about. You don't have to worry about imaginaries when they're in the numerator. That's an okay place for them to be. Because it means the numerator is closer to your brain so you can think about it. Once again, I'm really not that funny. You guys will miss me if you have Mr. Thames next year.
Wait, could I have you
What are you
explain
teaching
that?
next year?
I don't know.
I'm dropping out.
Let's do this one, please.
Like, could I like, Mr. Murphy, do this? Do you teach
I'm doing
stats
my
or
GED
anything?
this year.
Right. We don't know. I won't know until May.
You should like try and like be my teacher next year, so I got 3 years in a row. And then Mara and I will like sign up for the same classes so we can try and get
I'm going to do this route first.
That's not far ahead.
I already did this problem.
Okay, so 1 times 1
You were a lot quieter when you sat back there.
I won't. He's like,
Sit back there again.
There equals 2.
Willis.
Come on, Willis.
Say it again, bro. think they can.
Wait, so if it's a negative I, it would be like
So it'd be negative minus negative 1. Yes. What's the conjugate? All right.
-1 plus 1. This is how it looks like, right? That's how you say it.
So denominator, you guys should get 1 minus I squared, otherwise known as 2.
Minus? Wait, why do you put a minus in there?
Well, I've been doing these problems for a while. You've been talking for a while now. So let's think about what it means when you're multiplying two things together against FOIL, right?
No, not that. No. I thought you just replicated the bottom the denominator.
You would have been talking again at that point in time.
Just switch the I sign.
Remember we just discussed the thing called a conjugate? It's the same thing with the opposite operation between it?
Yeah.
No, you don't.
I
You're probably talking about
remember
one.
hearing it.
And then you multiply up to the top, you wind up with 3 minus 3i minus 4i plus 4i squared, which winds up as -1 minus 7i all over 2. -3 minus 4 is -7. 4i squared is -4. If it was -4i squared, it would have been +4. 3 minus 4 is -1. Okay? Tomorrow when we get to the quiz then, quiz itself is 5-1 through 5-4. 5-1 stuff is your graphing. Remember, can you identify where your vertex is? Is it a maximum, a minimum? Can you tell me what the axis of symmetry is? 5-2, factoring. With a equal to 1, with a out equal to 1.
Wait.
5-3 and 5-4 was your solvent equations. Some with imaginary, some without. Apparently, it sounds like you guys flew through that stuff from last night without too much of a hassle. And then lastly, there'll be a couple problems like this where you have to simplify, add, subtract, and multiply. And from the looks of how fast you're going through these things, it should not be that big. Okay?
What was the first one?
Yes, sir.
How many questions will there be on the graph?
Only a couple.
The graphing and symmetry.
Okay?
Wow.
What's that? What do you got? Yeah.
When we're pointing to 2 points that are close to each other,
Yeah.
do you just like
Use your table. Seriously, just use your table. What's there for? Do those. I'm giving you odds again. That way you can check your work. Remember, some of the solutions might be a little bit weird. Go with your gut on what you already have written down. Make sure that you always put it in that standard form with the integer value first before the I value. If you want to check your stuff, check your answers and all that in the morning, or show me what if you got questions. I'll be in here, so just pop in and I can help you out if you have any questions real quick. But I don't foresee this being a real difficult issue. On Friday we'll start with completing the square. Monday we'll do quadratic formula. Tuesday we'll start modeling. Wednesday we'll probably model. On Thursday we might have our presentations.
Model.
Wait, model.
I'm modeling.
I'll discuss it with you tomorrow.
Yeah, it's not.
Discuss it now. We have a couple minutes.
Wait, don't get rid of
Are
it.
you ever going to use this smart slate, Mr. Murphy?
I do every